There's a couple things I do want to talk about. Firstly, I want to show you this cool calculator technique. So what's going to happen, we'll just go into our basic run map and we'll follow these instructions here. We want to bring up this syntax so that it says sum, sequence, and then we can start to type in some things. So in run map, what we'll press is we'll press option, list, we press the across arrow twice. That brings up sum. We press the across arrow again, and that brings up sequence. Okay, so we've got sum, sequence. We just need to input a bracket in between them. Now what this is going to be used for is this is a fast way to calculate the sum of heights of y values. Okay, so what we're going to do here is we're going to make it perform the sum of these y values here, because then if we want the area, all we're going to need to do is multiply it by 0.5. Okay, if you think the area of these rectangles at the moment, it's going to be 0.5 times the height, I'm just going to call it height 1, the height of the first rectangle, plus 0.5 times the height of the second rectangle, plus 0.5 times the height of the third rectangle, etc. 0.5 is common, so we can factorize it, and what we're left with is the sum of the heights. So our calculator can do this for us. Now this might seem like a trivial example to do it for, but you might think of the e to the x function that we did last lesson with the exam question. That was quite challenging, and so if we can use our calculator to evaluate it all for us, it's going to be a much faster way of doing it, especially if we become comfortable with this syntax. So far we've just typed this in and we've got a bracket in there. What we're going to do next, we open another bracket and we type the function in here that we're interested in. So for the sake of this argument, we'll just go with this function to begin with, 2x plus 1. So we'll type in 2x plus 1. We put a comma because we are evaluating it for the x value. Okay? And then here's where we need to be a little bit careful, all right? This is where we're inputting the lower boundary and the upper boundary. We don't just go from 0 to 2. What we have to do is we have to go from the x value that corresponds with the first y value. Okay, so what that means is, here's the x value 0, and that corresponds with the first y value. So in this circumstance, our lower value is going to be 0. And our upper value of x is the x value that corresponds with the highest y value. So it's not going to be 2. All right, instead it's going to be 1.5. All right, so it's the x value that corresponds with the highest y value. So we're going from 0 to 1.5. And then we put another comma and we just put the width of each interval. And the width is 0.5. And we're going to close both our brackets and evaluate. And so that tells us the sum of all of the heights. Okay? 1 plus 2 plus 3 plus 4 is 10. Alright, so it seems trivial in this circumstance. So that's added all those up for us. And so then if we want the lower estimate, we would go 0.5 multiplied by 10, which gives us 5. So the lower estimate in this circumstance is 5. Let's choose a trickier example. Let's do y equals e to the x, and let's do 5 rectangles from 0 to 1. All right, so we can show you, and this time we'll do upper rectangles to show you how it's a little bit different. So the function e to the x is going to look like this, and if we're going from 0 to 1, and we want 5 upper rectangles. So the first rectangle, they all have a width of 0.2. 1, 2, 3, 4, 5. Okay, so let's figure out the syntax that we would type in for that. First, our function would be e to the x. Our x stays the same. Now the lower boundary, all right, is going to be the x value that corresponds with the y value. So here 0, x value 0 does not correspond with that y value. In fact, it's the x value of 0.2. Now we know it's 0.2 because we have 5, sorry, we have 5 rectangles in the space of 1 unit. Okay, so the lower boundary is going to be 0.2, and the upper boundary is the x value that corresponds with the upper rectangle y value, which is 1. And the width of all of these rectangles is 0.2. So if we evaluate that, all right, I need to type it in, not just. All right, so we'll have e to the x, and we're going from 0.2 to 1 with a width of 0.2. We've got 6, look how many decimal places it gives us to. Now remember, that's the sum of the heights. All right, so it's done height 1 plus height 2 plus height 3 plus height 4 plus height 5. And it's given us 6.5527. Okay.
That's not right.
Oh, sorry, I've still got a width of 0.2. Sorry, 1 to 1, 0 to 1.5. A 16.85? No. What have we done?
9.4, right?
So we've got e to the x 0.2.
Yeah.
I've got 1.5 written there. 1 and then 0.2.
Yeah.
9.47.
Yeah.
Nice. 9.47. 9.47916. Alright, so make sure we're putting in all the syntax properly. So that's the sum of the heights, but then the overestimate, remember we have to do the width times the sum of the overestimate. So we go that times by 0.2, and it's given it to us to, like, you know, what if we've got 8 significant figures here. Alright, and so now it becomes really easy to round. So for example, if we're asked to round to 4 decimal places, 4 decimal places means we would write 5 decimal places and round the 4th one. That would be 1.8958. Okay, so we will ask varying degrees of accuracy with rounding. Sometimes we'll ask for 4 decimal places, 2 decimal places. Sometimes we'll ask for 3 significant figures. Sometimes we'll ask to the nearest integer. Okay, so that's quite a useful process if you can develop comfort doing it. And no doubt in the practice test you'll have the opportunity to. Okay, it's much faster than working them out individually in the table and then adding them up together. Okay, and remember you've got a restricted amount of time, so you want to be as efficient as you possibly can. Okay, so that's the first thing. The other thing I wanted to talk about was I just wanted to point out 2 of the questions from the practice tests. So we're PRC 6 and we're 0297. Maybe you've done these already, maybe not. But we've seen questions reasonably similar to this. They pop up in all of the practice tests basically. You know, so it's just a good algebra question. So this is from the 2024 test. Alright, and basically it wants you to find the value of A such that this is true. Okay, so I just want to emphasize what that will mean. So the first thing we'll do is when we have this proposition, we'll often include stuff like where A is not an integer, but we'll show you the next example first. So what I want to say with this one is notice how when you perform it, we have half e to the 4 take 2e squared. Now these are not like terms. You cannot collect those together. Alright? They're not like terms because they don't have the same power. They will be like terms if they have the same power. So in this circumstance, we can't collect those parts together where my mouse is at the moment. And so consequentially, our answer, in our final answer, we haven't collected them together. Alright? Let's have a look at the 2023 test though. Okay, so in here, if we have a look at this one, we have, when we're processing it, we have minus half e to the minus 5 equals 2e to the minus 5. We end up moving it over to the other side, and these are like terms Because they have the same power. So if terms have the same power, even if they're fractions, all right, so for example, even if we had half e to the 3 take a quarter e to the 3, these are like terms because they have the same power, and half take a quarter is a quarter. All right, so if you can collect them, you must. All right, so look out for that. You'll see questions in the practice test where you can't collect them, and you'll see questions in the practice test where you can. When we want you to answer this, look at how they've found k. They've got k is equal to 1 on top of 2 ln 5. If we want you to write it like that, we'll be very clear. It'll say something like, express your answer in the form k equals 1 on b ln c. Okay, it might say something like that.
It says show that k.
Yeah, good. So this is a show that question. So here we've given you the answer. We won't always give you the answer. Just remember some tissues. We won't always give you the answer. Sometimes it might say present your answer like this. Okay, present your answer like this where, and we've talked about this notation before, where b and c are integers. Okay, so all that means is b and c are positive whole numbers. Okay, so when you see that notation, you know what it means. It just means you have to find the number of b and the number of c. And in this circumstance, b would be 2 and c would be 5. All right, so just so we're familiar with that notation. Okay, one more thing. I've got 2 more things actually. When you're performing the natural logarithm of a side, the reason I want you to collect it is because you can't perform the natural logarithm of a negative. Okay, so that's why we're collecting it. Just to emphasize, ln of x only exists if x is positive. Okay, so that's something we covered at the start. So you can never ln a negative. All right, and the last thing was when we're integrating something like this, technically in the description of the question, we should have integrate 1 on x with regard to x, provided x is positive. Okay, so that's what the question should say. Okay, because you can, if we're going to integrate this, the integral of 1 on x is ln of x, and that only exists provided x is positive. Okay, so just making you aware, in the test we're starting to knuckle down on our notation. We're going to be using that instead. All right, so it'll say integrate 1 on x provided x is positive anytime it involves an ln. So that's like a little bit of a hint. If it involves an ln or if it involves simplifying it, it'll say provided x is positive. Okay, so just to summarize, we talked about that calculator process. We talked about collecting e's, or collecting like terms if we can. We've talked about this notation here, what that means, expressing them as an integer. Okay, and lastly we've talked about provided x is positive. So you'll see that pop up to questions where it will involve integrating to an ln function. All right, any questions from you guys? No, so that calculator technique, you don't have to use that, but you're very welcome to.